Okay, back to our favorite reaction, the Haber process, the effects of temperature and pressure. So if you increase temperature, you're basically increasing energy, right? Because temperature, heat, it's like a type of energy. So when you increase temperature, which of these am I increasing? Which of these looks like energy? Oh, there it is. Okay. So when I'm increasing temperature, I'm increasing this energy. So just think of adding more heat is adding more energy. So if it says I'm increasing temperature, I'm like, oh, okay, I'm just increasing that energy. And now you can just go to that same rule of add away. So if I add more of this, the reaction is going to shift left, or you can call that backwards. And then I can just do my same thing I was doing before. What does that mean for N2 and H2? Well, they're getting made, so there's going to be more of them. What does that say for little NH3? Well, the reaction's shifting away from it, so it's kind of getting used up. All right. Okay. Decrease temperature, we're going to use the take away towards thing. And again, it's temperature. When it says decrease temperature, it means decrease the amount of energy. If you're lowering the temperature, less energy. So then you're doing the take away towards rule. Then you're saying, okay, if you take this away, we're going to shift towards it to kind of make more of it. And remember, shifting towards means just like more of that reaction's happening. So if more of that reaction's happening, we're saying, so we're always going to do these in two steps. Okay, what way is it shifting, and then who's being made and used up. So we got, okay, which way is it shifting? Now who's being made and used up. So for shifting right, that means that NH3 is being made, and these two guys are getting used up. Okay, and finally, what happens when you add pressure to a system? I always say it's like squeezing a balloon. I don't have a balloon, so this is a blown up plastic bag. But if you squeeze one side of the balloon, kind of like the other side bulges. And then if you squeeze that side, this side bulges. So it's like if you put pressure on something, it's going to kind of like, the air is going to like shift over to the other side where there's more room. So that's the rule about shifts in equilibrium with pressure. If you put pressure, it's going to shift to the side that has more room. And the side with more room is the side with less pieces. So if I look, the side with less pieces here, this has 1 N2 and 3 H2s. So this side has 4 pieces. This side just has 2 N2s. So this side has 2 pieces. So when I squeeze on this system, it's going to go to the side with less stuff, the side with more room. So that's how I remember it. You squeeze something, it's going to go to where there's more room. There's more room where there's less total moles of stuff, and you're getting those numbers from the number out in front. So that if I increase pressure, it's going to shift right. So then I go, okay, now that I know it shifted right, what was made? Okay, NH3 was made, and these two were used. So remember, it's like 2 steps to those. Let's do one more. If I decrease pressure, what happens? Well, if I decrease pressure, then it's like, okay, well, now we can go back over to the other side with less room. It's like you're doing the opposite. So if more pressure makes you go to the side with more room and less stuff, less pressure's decreased pressure is going to do the opposite. So now I'm shifting left. So that's always step 1 of these problems. Which way am I shifting? Now that I know I'm shifting left, who's being made and who's being used up? N2 and H2, the arrow is pointing at them, so they're being made. So there's going to be more of them made. And NH3, the arrow is pointing away from it, so it's being used up. So it's going to decrease. All right. So again, if you're dealing with temperature, it's still add away, take away towards. It's just now you're saying, okay, well, this energy represents temperature. The rule with pressure is the only one that's a little different. If you increase pressure, it's going to shift to the side with more room, which is the side with less moles, or a smaller number of coefficients. So here's the note about this. If you increase pressure, it's going to shift to the side with more room. This means the reaction will shift towards the side that has less total moles, and that is the number out in front. Okay, that's this 1, this 3, making this side 4, and this side is 2. So it's those numbers out in front. So then again, once you figure out which way it's shifting, then you decide who's being made, who's being used up.